In order to make LINQ work, they have to have specific language features that enable the dynamic nature of LINQ queries. In Visual Studio 2008, both Visual Basic and C# were extended to include the following features: implicitly typed local variables, object initializers, lambda expressions, extension methods, and anonymous types. And throughout this section and the next, we'll be looking at each of these as they apply to working with a very simple sample application that really has nothing to do with LINQ. We'll just use these features that were added because of LINQ. Now, the sample application really consists of just a single procedure. It accepts a parameter indicating the location to search for files, and given that path, it iterates through all the files in the specified folder. It adds each file that's found to a list of file info objects. Once that list is created, the code iterates through the list and displays the results in the console window. Now, as we add more functionality, we'll add more complexity as well and more features. For example, we'll limit matching files based on some criteria that you might want to specify. Let's look at the first version of this code to see how it works without any of the new language features. Let's start by demonstrating a version of the procedure that doesn't use any of the new LINQ language features. Press A, here we are. And now I'll step into my first procedure. And in this one, we're going to use no LINQ features. We're going to fill a list with names of all the files in the folder we're looking in. Now, right now, the path is C:\Windows. We'll create a new list that contains strings. And for each file info object that we find, by letting the directory info, given the path, call its getFiles method, we'll add the file's name property to a collection of strings. When we're done, we'll display the entire list, and there you are. And that works fine. But what if you actually want more information about the file than just its name? Well, then you might want to create a class that contains just the properties you want. So in example B here, we'll step into this, and now we're not going to use just strings. We'll use an instance of a class named myFileInfo. If we go look at myFileInfo, here it is. You'll see that it has three public properties: a string for the name, a long for the length, and a date time for the creation time. It's got a default constructor and a constructor that allows you to pass in the name and specify just that one property. It's got a toString override for the built-in toString method that prints out a formatted version of the creation time, the length, and the name. Okay, well, back to our code then. Here, we're going to create a generic list containing myFileInfo instances. And for each file info that we find in the directory info's getFiles method call, we create a new instance of myFileInfo, and we copy over each property individually. Name gets put into the name property, length gets put into the length property, creation time into the creation time property, and then we add the new myFileInfo instance to our generic list of myFileInfo objects. I'll press F5 to run full speed, and you'll see that in the console window we have formatted output containing the creation time, the length, and the file name. I've set up my format string so it looks very much like the dir command in a console window. But in any case, we haven't used any of the new LINQ features yet. I've only showed off how you can get the base functionality working. Now I'll whine a little bit and say, why can't we do this easier? And start adding some LINQ functionality, that is language features provided by LINQ, to make this more full-featured. If you noticed, when we created the generic list of myFileInfo, the code in the sample defines the type of that variable twice. What if you want to modify it to allow the compiler to infer the type from the instantiation on the right-hand side of the equal sign? When you're writing LINQ and working with anonymous types, this is required. But in code like this, where we're not even using LINQ, it can still be a useful feature. Let's take our original procedure and modify it to save a little bit of typing. Here, in a sample procedure, I want to show off a couple of different ways to implicitly declare variables. Here, when I say var I equals 25, the compiler knows that I is an integer. As a matter of fact, if I hover over it, it should tell me that I is the value 25, and it is an integer. And that's the same as saying int I equals 25, but really, this is not a good idea. I would suggest that you avoid that sort of ambiguous use of implicit variable declaration. Here, however, there is no ambiguity, and it does save us time. Remember how we declared the variable, the list of myFileInfo, and we had to put list of myFileInfo on both sides of the equal sign? We get the same exact behavior declaring it this way. That is just saying var myfiles2 equal new list of myFileInfo. You can look on the right-hand side and know exactly what type myfiles2 will be. Well, let's modify our existing procedure to see that in action. Here we'll come into the third version of this procedure. Here we are. And really, the only change here is I've used var where I could. So here I have var files equals new list of myFileInfo. So instead of having to type this long declaration, I have this short one. Here, for each var fi in this collection, well, I know this thing returns a collection of files. I don't need to explicitly say FileInfo fi. I can say var fi. And down here, when I declare my new FileInfo object, I don't need this on both sides of the equal sign. I can just say var myFile equals new myFileInfo. Is this worth using? It's up to you. Certainly in a case like this where there was lots of typing, sure. Down here, maybe not. Here, maybe not so much. But it certainly hasn't made the code any less readable and can help save you typing when you're writing your own code. When working with LINQ and anonymous types, there are many times where you can't avoid using the var keyword because you don't know explicitly what the type is. Here we do. It's just used here to save typing, and that's all. If we run the code, of course, we get the same exact results we got before. If you remember, our sample included code that used several lines to initialize the properties of that myFileInfo instance. Here we'd set var myFile equal new myFileInfo, and then set the name property, the length property, the creation time property, each by copying values from fi into myFile. And then we added myFile to the collection of files, and that's how code's always been written. It seems perfectly reasonable. Now you could, if you were rewriting the myFileInfo class, you could include a constructor that allows you to set them all, but right now it doesn't have that constructor. But if it did, you could say var myFile equals new myFileInfo and pass in the name, the length, creation time at the time you construct the object and then add the object to the collection. So 2 lines of code. Or even simpler, you can do it in 1 line of code. Files.add, new myFileInfo, and pass to the constructor fi.name, fi.length, and fi.creationTime, but that constructor doesn't exist. But what if you could take advantage of the new feature added for LINQ that makes it easier to work with anonymous types? That is, the ability to call a constructor that really doesn't exist. Let's look at an example that demonstrates that behavior. I'll choose option E to review object initialization. And this one uses a new syntax provided by LINQ to make it easier to create instances of objects and set their values at the time you construct them. Here, code's all the same until we get down to this point. We're declaring var myFile is new myFileInfo, but here in curly braces, not regular parentheses, but curly braces, we specify field name equals value, name equals fi.name, comma, length equals fi.length, comma, creation time equals fi.creationTime, and by doing that, you're setting properties of the new instance of myFileInfo without having to write explicit lines of code to set those values. Once we create that new myFileInfo object, we can add it to the collection of files, and we'll repeat this for each file and we end up with the exact same set of files. Now remember that the MyFileInfo object also included a constructor that took a value, a parameter. And so you can mix and match your methods. So here, for example, when I'm creating the new instance of the MyFileInfo class, I'll specify the name as a parameter to the constructor because I can do that. And then in the curly braces, only specify the length and the creation time. It simplifies the code even farther. So if you have a constructor that allows you to pass values, you should use them. But if you don't, you can still use this LINQ-focused syntax that allows you to specify values of properties of your object at the same time you construct the object. And here we'll add each one to the collection, and we end up with the same exact list of files. We have a third version here as well that makes this a little bit tighter. And this version doesn't even bother using the extra object. In this case, when we create the new MyFileInfo, we just store it directly into the collection. We call files.add, and we pass as a parameter to the add method the new MyFileInfo instance, where we pass the name in the constructor and then specify the length and creation time using the new object initializer syntax at the same time we create the object. So in one line of code, we create it, initialize it, and add it to the collection of files. And of course, we end up with the same list of files again.